we know that. So we are going to draw our diagrams, our free body diagram. Okay, so we know that this is our point A, point B, and this is our point C, right? So point B, we have a 120 times 10 to the power 3, right? So this is our V at point C. Okay, and then this will be our moment at point C, right? So we are also aware of the distances, okay? So we know the distance from here to here. Now this is fixed. Now this is at 3.2 meters, right? And then we are also aware of our distance from here to here. This is 0.8, right? And then we are also aware of our distance from here to here. This is 2.4. And then over here we have 50 times 10 to the power 3 multiplied by 3.2, right? And then the distance over here to here, right? So this is 3.2 divided by 2. So this is 1.6. Okay, so that is our 1.6. So from here, we are again going to do the same thing. Okay, so we are going to look at left to right analysis or static analysis. And then left to right. Okay, left to right. So from here, positive is going up. See the same thing, right? So this will be equal to 120 times 10 to the power 3 minus by 50 times 10 to the power 3 multiplied by 3.2, right? And then this is minus VC is equal to 0. Okay, so VC will be equal to 120 power 3 minus by 50 power 3 times 3.2. So it's equal to minus 40. Okay, so it's equal to minus 40 times 10 to the power 3 Newton. So that's a constant, right? Then we do moment about Z at point C. So I know old tape recorder, this is where the datum is, right? So now we are looking at 120. So 120 is going to be negative. So this will be equal to minus 120 times 10 to the power 3 multiplied by 2.4, right? Then the next one will be plus 50 times 10 to the power 3, then multiply by 3.2, and then multiply by 1.6, and then plus by moment about point C. So moment about point C, right, will be equal to 120 power 3 times 2.4 minus by 50 power 3 times by 3.2 times by 1.6. So it's equal to 32,000. So 32 times 10 to the 3 Newton meter. Now you can also check this, okay, if you want. Okay, you can also check this. So I'm just going to do moment. Okay, so now if moment is equal to 3.2, okay, on the previous equation, so you will have minus 25 times 10 to the power of 3 multiplied by 3.2 squared plus by 120 times 10 to the power 3 multiplied by 3.2 minus by 96 times 10 to the power 3. Okay, so this is going to minus 25 power 3 times by 3.2 squared plus by 120 power 3 times 3.2 minus by 96 power 3, right? So I get 32. Okay, I get 32 times 10 to the power 3 Newton meter. So now you're very sure, like your equation is like, or your answers is spot on. Okay, or now you can confirm, right, that your equation for B to C is correct. Now let's try another way of doing it. Okay, let's try. So now I'm still going to focus at point C. Okay, we are still going to focus at point C.
Sorry, Eugene, for the moment that you just did, why is it multiplied by 3.2 and then by 1.6?
Did I write? Oh, this is because where we get a 1.6.
Oh, I see. Thank you.
Okay, this is because of the distance. This is because of the position of the centroid or the equivalent load. Okay, the 3.2 is a 1.6 equivalent load. Okay, now let's do this another way. Okay, so I don't want you all to be a one X or one show, right? Or something that only can do one thing. Okay, I'm going to change this, and I'm not going to enforce you to use it, but you decide, because it will also dictate what is the term. You also will let you see how much easier. Okay, so what I'm going to do now is I'm going to do this. Oh yeah, the term I'm going to use is one pony egg. Okay, I don't want our student to be known as the one pony egg. Okay, you have to do different stuff. So now we know that this distance is 3.2. Okay, and this distance from here to here is equal to 0.8, right? And we have a load coming up here, and this load is equal to 40 times 10 to the power 3, right? And our geometric datum did not change, right? So what changes now? Again, it is a positive shear, positive bending moment. Analysis is from right to left now. So this is our V at point C, and this is our M at point C. Okay, that's our right. So we are going to again static analysis. And now we are going to go from right to left. Okay. So positive is going up, right? So you have 40 times 10 to the power 3 plus by V at C, 0. V at point C is equal to minus 40 times 10 to the power 3. Okay, that is our V at point C. Okay, and then we do summation about moment in the Z direction exactly at point C, equal to 0. So you have so now we are where we are taking our moment is we are taking our moment here. Okay, so now it becomes what? So now it becomes relative from point C. The 40 is going in an anti-clockwise direction, so it's positive, right? Then plus, oh yeah, wait, minus, right? So with this moment at point C, right, is 40 power 3 times by 0.8 is also 32. Now, question for you guys. I'm lost of word now. Now you can see left to right and right to left, right? Now, which one do you all prefer to use? Anyone?
The one you just did seemed easier.
Yeah. Why it seems easier? Because what? You only have one load and you only have one what? Distance, right? So if you look at the number of component, you only have one load, you have one distance. So the likelihood of making mistake is less, okay? Is less. Over here, you have one load, two load, one distance, two distance, three distance. So the more components you have, the more likelihood that you will make a what? Mistake. And that is normal. That is what is expected. It's normal. Okay, so that's why you want to have less mistake, easier to check. I will do right to left over here. Okay, I'll do right to left hands down, right? Because there's only one force and one distance, and you cannot F it up, so called. Okay, are we clear? Okay, that's why I want you to as I say, I want you to observe this. I'm not going to force feed you. Okay, you want to use it, good. You don't want to use it, you can still get the right answer, but it takes more time. Okay, right. So now we are going to do point C to, so before I go on, okay, so we have found our relationship. I have to dim my brightness, because if I don't dim the brightness, the freaking computer will crash. Okay. So we know now over here the x, which is 3.2, over here, what do we say it is? Is it minus 40? Yep. So this is minus 40 times 10 to the power 3. Okay. And this will be 32. Okay. And then the last range, or we're going to form this last equation. Okay. So as I said, objective is to show you you can do left to right, right to left, and you just found which is a easier or which is more effective way of doing it. Okay, as I said, both answer has to be the same. Okay, so now we look at point C to point D. So now it's 3.2 x 0.8. Yeah, right. So I'll still do from I'm going to do it from right to left. So this is my x distance. Yes, this is my x distance. This is where my slider is. So this is where my point D is. Okay. So hold on. I have to draw this correctly. I just draw something wrong. Right. So is this system we're going to take, right? So over here we will just have a force that is what, the 40 times 10 to the power 3, right? So the distance from here to here, right? So that distance is important. Okay, that distance is important. So the distance from there to there is equal to 4 minus x, right? So again, v as a function of x, v as a function of x, moment as a function of x. Okay, so for this case, I'm going to write down static analysis. From right to left, right? So this will be equal to positive. This is equal to 40 times 10 to the power 3 minus or plus v as a function of x is equal to 0. So v as a function of x is equal to minus 40 times 10 to the power 3. Now this is not a constant. Sorry, this is not just one number. It describes a distribution from 3.2 x to 4.0 at minus 40. So it's a flat line. Okay. And then finally, moment z at point x, okay, is equal to 0. So this will become so we're going to take datum, not datum, we're going to take our moment from there. So it's going to be anti-clockwise. So it's 40 times 10 to the power 3, 4 minus x, right? And then plus, sorry, again minus, wait. Yeah, clockwise is minus. M as a function of x. So M as a function of x is equal to minus 40 times 10 to the power 3x plus by 160. Okay, plus by 160 times 10 to the power 3.